Hi guys, and welcome back again to Physical Sciences for Year 10. In this explanatory video we're going to be looking at the concept of bearings and vectors so that we can use this when we're dealing with any form of motion. Okay, so to deal with a bearing or a vector we're going to actually just use compass headings in this case. Now there is a mathematical way of formulating a bearing using three significant figures. I'm not going to go into that area here because we're not going to be using it in the assessment. However, we will be using it later on in Year 11 Physics, so be aware of that. You may touch on it in maths, but for now we're just going to be using the compass heading. Now we know the compass heading is made up of 4 points. We've got north, east, south and west. We also know that there are 360 degrees in a circle, but there's 90 degrees between north and east, east and south, south and west and north. So basically when we're looking at a bearing, we're looking at in which direction are we going to be heading, and then we can turn that into a vector by stating how far we're then going to go in that direction. So the bearing is really going to give us the direction, the vector is then going to give us an overall of the distance travelled or the speed travelled in which direction. So how do we write this? Well, when we calculate or write our bearings, what we have to write it as is we show our direction that we face initially, then we turn through an angle, and then we state in which direction are we going when we turn through the angle. Now that's a little bit confusing, but if we just run through it briefly here, I'll explain it in more detail in a minute. So this is how it would look. For example, I might go east 47 degrees south. So what does that mean? Well, the direction I would face if I'm standing right at that center point in the crosshair of that compass heading, I would face east initially. So I'd take my compass, I'd find where east is, and I'd look in an easterly direction. The 47 degrees means I'm going to move 47 degrees. Now I may move 47 degrees north, or I move 47 degrees south. Now, if I'm standing in that center point, I could move upwards 47 degrees or downwards 47 degrees. Nothing tells me which way to go yet until we get to that second symbol, the south, the S. Now the S tells us the direction we've got to move. So if I'm standing facing east, I'm going to move 47 degrees in a southerly direction. So I'll be pointing in that direction over there rather than pointing in that direction over there if I'm facing straight east. So my bearing when I start, so if you imagine I'm standing here, okay, I'm looking east, I turn 47 degrees. Do I turn 47 degrees this way, or do I turn 47 degrees this way? Now in this case this is going to be my north, this is going to be my south. My heading says turn 47 degrees in a southerly direction, so I must turn 47 degrees in a southerly direction. Now what that means is if I'm facing in this direction, I don't know how far I've got to go, but my displacement or my distance will tell me, or my speed will tell me in which direction I've got to move. So that's how we'll write our directions when we're doing our bearings. Okay, so let's just show that in a little bit more detail so you can follow it. So here's my bearing, east 47 degrees south. So from home, I look in an easterly direction, I move 47 degrees in a southerly direction, and then my final direction that I'll be facing will be that arrow which is on the diagonal. I hope that makes sense. So whenever you write it, you always write it in that format. Direction I go, the angle I move through, and then the direction I've got to move that angle. Hopefully that will make sense, and with a little bit of practice it will become clearer. Be warned, this is advanced stuff, so don't worry too much if you're struggling, because I will run through some simple vectors and bearings which work just on a plane level. So but as you follow this through, I hope that you'll be able to grasp it quite quickly, because it's not a difficult concept once you follow the rules. Okay, so how do we work out the angle? Well, unfortunately, we're going to have to do a little bit of maths. So we're going to have to use trigonometry. Now, I know you've all studied trigonometry at this point, or should have studied trigonometry at this point. for quite a while. So let's just recap. If I've got a right angle triangle and I'm standing where the red dot is, the angle that I move through can be worked out from a right angle triangle. Now notice that the adjacent bit, the ADJ, is sort of my easterly direction. Now if I'm facing the line facing directly facing me is the opposite, and then the hypotenuse is that long line of that right angle triangle. So we're going to try and find the angle X. Okay, that's the one that we need to find. So how do we do that? Well, if I've been given the direction that I'm traveling with the opposite and the hypotenuse, I use sine. Okay, so I put into my calculator use the sine value. I do opposite over hypotenuse. If I've been given the adjacent and the hypotenuse, I do cosine x equals adjacent over hypotenuse. And then if I've been given the adjacent and the opposite, I then use a tan. Now in most cases you'll probably be using the tan value. And the tan value is the opposite over the adjacent. Now as we run through this, and again this is really pushing that A grade area, we'll be running through this. Now most of you will know this as SOHCAHTOA. SOH is the sine, COAH is the car, and TOA, TOA, is the tan component of SOHCAHTOA. So you can use that as something that you can remember. So that will give us the angle if we're moving on a specific bearing, but we also need to work out the distance travelled. Now the distance travelled of a right angle triangle can be calculated using Pythagoras. Now again, you've covered Pythagoras in year 8, so in year 8 maths, so it shouldn't again be a problem. Now of a right angle triangle, the formula for Pythagoras is c squared, the hypotenuse, equals a squared plus b squared. So obviously if I want to find the direction, the distance of the hypotenuse, it will be the square root of a squared plus b squared. So I've put that there just to jog your memory. Again, I've got an example that we'll work through which will allow you to really hone your skills. And if you go to the iBook as well, these examples will be there, and there'll be an extra little video for you to watch in the iBook. Okay, so let's take a very, very simple vector situation. A simple vector will allow us just to work on one plane, i.e. either going left to right or up and down or forward and backwards. Now, what we need to do is to be able to ascertain which direction we're going in. Because we're dealing with vectors, we've got to have direction. Now, maths makes life easy for us. Some of you may not think that, but it does, because it's logical. We state we can use positive going one way, negative going number. Remember your number lines when you were quite wee, you basically had positive going in one direction and negative going in the opposite direction. It's exactly the same. So when we're talking about direction, we'll let going to my right equal positive and then going to my left equal negative, or going to my left being positive and going to my right being negative. Then when we do a calculation, when we add them together, we use these symbols. It's important that we use these symbols to find the direction. The symbol will then tell us where have we gone. Okay, what direction have we gone in order to finish that final situation. So let's have a little practice and see how it goes, because it will become clearer in a second. So here's example 1. We basically state that an object moves from home 15 meters east and then moves 5 meters west. And we want to work out what is the object's distance traveled, how far did it go in its whole journey, and its displacement after traveling this journey. Now we're going to draw a diagram in order to help us. So we put home up, so there's home, okay, and what we're going to do is we're going to travel 15 meters in an easterly direction. So there we go, we've gone 15 meters east. From there, we then move, we turn around and we go back in the opposite direction, 5 meters. So we then go 5 meters west. We will end up where that arrow basically, where the bottom arrow finishes on that top arrow. So that will make sense in a second. So what we've got to do first is ascertain which one are we going to call positive. Well, let's have going east equal positive. So we'll make east be positive. Now the first question asks us, what's the distance travelled? How far have we gone? Well, we did 15 meters and then we did another 5 meters. So we did 15 plus 5, so we travelled 20 meters. We actually walked 20 meters. We went 15 meters this way and then came 5 meters back, so our total distance travelled was 20 meters. But what's our displacement? Where do we end up from home after we've done that journey? So the displacement is how far do we end up from home. So we need to state we went 15 meters positive and then we came back. So back would be negative, so opposite direction, 5 meters. So we went 15 meters in one direction, so plus 15, and then we went plus 5 meters, but in the opposite direction, so we put the negative. So we end up, and if you notice, if you remember from your maths, a positive and a negative joined together is the same as a negative. So it's 15 minus 5 equals 10 meters. So what does that mean with respect to displacement? The displacement was that we were 10 meters east of home because we were that value is a positive. Okay, so we were 10 meters east of home when we finished. Hope that makes sense. Let's do another one. Okay, so we've got an object, and in this case it moves 5 meters east and then moves 15 meters west. What is the object's distance travelled and its displacement after travelling the journey? So let's draw a diagram again. Okay, so there's home. So what do we do first? Well, we move 15 meters east. So we go to our right, 15 meters. Then what do? We turn round and then we go 15 meters in the opposite direction. Okay, now the total distance travelled, just as always, and sorry, in this case we're going to use east again being positive. The distance totally travelled, we went 5 meters and then we did another 15 meters. Again, it doesn't change. We've gone 20 meters. However, the displacement will say how far do we end up from home. So we went plus 5 meters because we're going to say going easterly is plus 5, and then to that we added a negative 15 meters. So we then get this scenario. We end up having plus 5 plus minus 15. The minus 15 meaning we're going in the opposite direction. So the plus and the minus combine together to make a minus. So we get 5 minus 15 equals minus 10 meters. Now what does that minus 10 meters mean? It means that positive is to the right, negative is to the left. So we ended up 10 meters to the left, or 10 meters in to the west of home. So the final displacement is 10 meters west of home, as it's a negative value. Notice I've got my distance there and I've got my displacement. So in this case we're dealing with those first few variables. We're dealing with distance and we're dealing with displacement. Okay, so that deals with working on a planar value. And if you watch the iBook, I've put some more examples on there which will help you going north and south, forward and back, left and right, and hopefully they will help. So let's look at a more complex one. This one where is going to be looking at dealing with trigonometry and Pythagoras. So this is going to be going at an angle. This is what you will require for your test. Okay, however, if you really want to push into that A grade area, the next example, this example here, is going to be the one that you're really going to want to get to grips with. You just follow the rules and you'll be okay. So in this case, what we've got an object that moves 15 meters from home in an easterly direction. So let's put it down. There we are, where's home? We've gone 15 meters east. We then move 5 meters north. So we go north and 5 meters. Now, what we want to know is the total distance traveled. Well, the total distance traveled is a scalar unit. Remember, distance was scalar. Okay, so we went 15 meters, then we went 5 meters. So that's fairly straightforward. We know what that one's going to be. but the displacement is basically how far do we end up from home, which is going to be the arrow in red. Okay, we want to know how far did we end up from home and in what direction. Now you'll notice here that we produced a right angle triangle, so it allows us to use trigonometry and displacement. Okay, so in this case the distance travelled, we went 50 meters, then we went another 5 meters, so we did a total journey of 20 meters. Finished. Notice it's scalar, don't need any direction there. But I want to work out what my displacement is. Now notice my displacement has often been different to the total distance travelled because it's how far I end up. So for my displacement I need to work out what is the distance travelled and what is the direction. So displacement, as I said, has a magnitude and direction, so we use Pythagoras to work out the magnitude and we use trigonometry to work out the direction. Okay, so let's do that. So let's look at the magnitude of the displacement. So in order to do that, there's my triangle. I went 50 meters east and then I went 5 meters north. I want to find out what is the magnitude of C. So remember that Pythagoras is c squared equals a squared plus b squared. So I follow this through to calculate C. I do square root of a squared, which is 15, so it's 15 squared, plus b squared. B is 5, so it's 5 squared. So it's 15 squared plus 5 squared. Do that first and then work out what the square root of that value is, and it's 15.8 meters. So that's my magnitude. Notice it's different to the distance travelled, okay, because this is going to be how far away from home I'm going to end up. So I know how far away I'm going to be, but am I going to be going from home 15.8 meters this way or 15.8 meters this way? And what's the angle that I'm going to move through? So that's what I'm going to find out next. So the direction of displacement can be calculated using trigonometry. Okay, so I know that I'm going to be going in a northerly direction because I was told to go north. So I want to find the angle X, now which is in the bottom left-hand corner of that triangle. So I know I've been given the adjacent, that's 15, and I've been given the opposite, which is 5. So I use my tan value. So tan equals opposite divided by adjacent, but I want to find the angle. So what I have to do is I have to do a tan to the negative 1. Now you will have done this before, but all I have to do is put in tan shift tan to the negative 1 on your calculator, then in brackets do 5 over 15, close brackets, hit the equals button. That will give me my angle. If you do the same each time, you're not going to have any problems. So now I've got my total distance travelled, 15.8 meters. I know the angle that I've moved through, and I know from my question which direction I moved through, because I went in a northerly direction from east. So when I pull it all together, the displacement comes up as I ended up 15.8 meters east, 18 degrees north of home. Okay, so I'll say that again. From home, I ended up, by doing this 15 meters east and then 5 meters north, I ended up 15.8 meters away from home, east, 18 degrees north. Okay, well I hope you found that useful. So what I'd like you to do is go to the iBook, and there's an exercise in chapter 3. Note it's chapter 3 and it's exercise 1.1. Have a go at those questions, and by all means you check the answers in your iBook. As I say, go and read the section on vectors and bearings in the iBook, and there is another video in there which will run through a few more examples. Thanks for watching, and join me again.